Hello everyone. So today we are going to understand an important concept in data structures and algorithm, which is binary search algorithm. So binary search algorithm is used in lots of problem in while solving data structures and algorithm. And if you are if if you are improving your fundamentals in data structures and algorithm, then binary search algorithm should be in your problem list, because lots of company ask direct questions as well as application based questions on this algorithm. So I hope so. If you are doing this, then this video is for you. So first of all, uh, uh, where does binary search algorithm is used? So as the name suggests, binary search algorithm is a search algorithm where in which you are given a target element and you need to find that target element in the array. So one important thing which we need to understand is that while solving problems in on binary search algorithm, the array should be sorted, otherwise there is no use of applying this algorithm. So I have a question, which is an array ARR of elements 2, 4, 7, 9, 11 and 12, and we need to find a target element in this array, which is 7. So target element is basically 7, and we have an array of elements 2, 4, 7, 9, 1, 1 and 12. So how we will apply this algorithm in this problem? So for applying this algorithm, we need to have two pointers, which is the low pointer and which is the high pointer. So the low pointer will be starting from 0th index of the array, and the high pointer will be going to start from the n-1th element of the array. So I will be starting from 0, and the the low will be starting from 0, and the high will be starting from n-1 which element. And we will what we are going to do is we are going to find another index on the basis of the low and high index. So for finding this index, we are going to do low plus high by 2. So it is like finding an average of index. So this the low plus high by 2 will give us the mid index. So this is the new index, which is mid index. We are going to find by low plus high by 2, and we will check the element on the mid index. If the mid index is greater, if the element on the mid index is greater than the target element, then we are going to shift the high index from n-1 to mid -1th index. So currently my low index is 0 and my high index is 1 2 3 4 5 6. 6 is the number of elements, so 6 minus 1, which is 5. So 5 is my high index, and 5 by 2, which is 2, will be my mid index. And for my current array, my element on mid index will be 0 1 2, will be 7. So directly I got my target element, which is 7. So basically there are two scenarios in this algorithm. Which one is, as I said earlier, means one scenario where target element is greater than element at mid index. When target element is greater, then what we can do is we can shift the low index from 0. We can shift the low index to mid minus 1 index. So by doing this we can compress the search region, and when the target element is less than mid index, then what we can do, we can shift the high index from n-1 to index at mid minus 1 position. So this will also decrease the search region of the array. So we will be doing this process until we get the target element equal to element at the mid index, and we will be getting our target element. So this is the problem, and if the target element is not present in the array, then we are going to directly return -1. So the question is, what will be the time complexity of this problem, of this algorithm? So the time complexity for this algorithm will be big O of n. Why big O of n? Because we are traversing every element one time. If the element is not present in this region, then we are going to shift towards that region. And if that element, this was the scenario 1, and if element is not present in this region also, then we are going to shift in this region. So after time to time our region will get compressed and we will get the element. If there is no element, then we are going to return -1. So that's why we are traversing whole array one time. So that's why the time complexity of this algorithm is big O of n, and the space complexity is constant, which is big O of 1. So now I will be writing the pseudocode for this algorithm. So first we have element at 0th index, and we have other I have my first index which is 0 and the second index j which is at n-1. So you can use any name. I am using j for this pseudocode, and I will be going to find my mid index using I plus j by 2. So I am going to use while loop. If I is less than j, then go into the loop, find the mid index at I plus j, a of mid. If a of mid is less than target element, then shift I from I to mid plus 1, else j equal to mid -1. Else if we got the element which is equal to target element at mid index, then we are going to directly return that element, which is we are going to directly return it, and otherwise if element is not present, then we are going to return -1. And this is the pseudocode for this problem, and Thank you for watching this video till end. Until then, see you next time.